Good morning or good afternoon or good evening. Today we're going to look at congruent triangles and more specifically how to prove that we have congruent triangles. So we're going to talk about what's the bare minimum that you need to prove that your triangles are congruent. Now, if you remember from the other day when we talked about congruent triangles, we talked about having two triangles and we were looking for ticks on all the sides. We were looking for arcs and matching spots like this. But you actually don't need all of those things to prove that triangles are congruent. There's just a minimum number of things that you need, and that's what we're going to get into today. So, some things that work that our minimum would be is if you have a side, an angle, and a side that match. So, if you have a side, angle, and side that match, I'm just going to say SAS for short. So, S would stand for side, and A would stand for angle. And the way that side, angle, side would work is if you had two triangles, and in those triangles you have two sides that match with an angle between them, hence SAS. So SAS would work as if you had two triangles, and so you had two sides that match, and then the angles between the sides, so you should see an arc between those ticks. Okay. Another way to prove that triangles are congruent would to be by side, side, side. Now, side, side, side is everybody's favorite. Side, side, side just means that you're looking at a triangle and there should be ticks all the way around. That's it. Is if all the sides match up, all the ticks match up, you're good to go. Another way that would work, or minimum, is if you have an angle, side, angle in that order. I'm going to show you what that looks like in just a second. So if you had angle, side, angle, that would work to prove triangles are congruent. So would angle, angle, side. That would also work. So there's 4 ways that prove that triangles are congruent, and there's one more option that we have, and that's for right triangles only, and that's HL. Now, A stands for angle, and S stands for side, but HL works in a right triangle, meaning that we have to have 3 things. 1, it has to be a right triangle. It has to be a 90-degree triangle. 2, the H stands for the hypotenuse, so the hypotenuses have to match. And then one of the legs has to match as well. And if you make an L with your hand, those are your legs in a right triangle. So HL would be if you had a right triangle, the hypotenuse matched, and then one of your legs matches. So either a tick there or a tick there, one of those spots, that would be HL. Now, the 2 that people tend to struggle with in how to prove triangles are congruent is angle, side, angle, and angle, angle, side. Similar yet different. So, angle, side, angle has a side between 2 angles, which means that in my picture, I'm going to go ahead and I'm going to mark 2 angles. Now, angle, side, angle means that my side, my tick, needs to be between the 2 angles. So I don't want to put my tick over there. I don't want to put my tick over there. I need it between my angles, which means that my tick should go right there for angle, side, angle. And what we say is that the side is included. We don't really use the word between. I do, but the math word is included. For angle, side, angle, that side needs to be included between the angles. Now, the alternative to angle, side, angle is angle, angle, side. Now, angle, angle, side looks very similar to angle, side, angle. 2 angles mean that I should have 2 sets of arcs. So 1 arc, 2 arcs. So there's my angle, 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 angle. But that S, that side, now goes on the edge. So I could go this way and do angle, angle, side and put a tick over there on the edge. Or I can go around this way and do angle, angle, side right there. So it doesn't matter, but right here, this is not included, known as our excluded side, which means that it can't go between them. It has to go here or here if it's excluded. And it doesn't matter. I'm just going to go ahead and put a tick right there. Now, the key thing to remember here is that angles have arcs, so you're looking for matching arcs like that, and sides are ticks. Now, these 5 things work, and we're going to look at some examples of those in just a little bit. Some things that do not work is if you only see arcs in a picture. If there's no ticks, there's only arcs. So like double A, two angles, or triple A, those don't work. You need to have a side into the mix for you to prove that the triangles are congruent. Angle, 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 angle doesn't work. And neither does side, side angle. If you have two sets of ticks with an angle on the edge, that doesn't work. And our little phrase that we like to say in geometry is no batteries. So no double A's, no triple A's, and we also like to say no batteries and no buts. I'll give you a minute to think about that no buts part. So no batteries, no buts in geometry. So let's take a look at a few examples. So we're going to go through and ask ourselves, tell which postulates, if any, would make these triangles congruent. So I'm taking a look at this first picture and I see a tick and a tick, so a side and a side. I see ticks here, ticks there. So they have one side in common, and then they have two sides in common. But then I also see three ticks here and here, which means that they have three sides in common. If we go back to our chart, side, side, side works. It proves that our angles are congruent. So are these two triangles congruent? Yes, by side, side, side. Now, before I write that down, I am going to check really quickly our congruent statement and make sure that they did the right order here. Because this says that A should go with E. Well, does A go with E? Is it between one tick and two ticks? Yes. And C should go with D and B should go with F. So I'm just going to check C is between two ticks and three ticks. D is between two ticks and three ticks. So yes, we were right. Our triangles are congruent by side, side, side. Now in this next picture, if you notice, the triangles are adjacent. So the triangles are next to each other. It's talking about two different triangles. I'm going to go ahead and outline them in colors. So this blue triangle is ABC. And then I have this green triangle that's CDA. Now, I see a side matches with a side and a side matches the side. So I currently have side, 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 side. But SS isn't enough. But I do have a freebie here, and that's ask yourself, is CA the same for both triangles? If this is 5, is it 5 on the other side as well? And that answer would be yes, it is the same, which means I'm allowed to add ticks here. Okay, and I'm allowed to add ticks because CA is congruent to CA, reflexive property. So I have a freebie here, and that's reflexive property. As we go through several of these examples today, you're going to notice that we have some what I like to call freebies. Freebies are just things that I can put on my picture that I'm allowed to add on my picture. They're legal moves. So for example, if they have a side that's like touching adjacent like that, they share it on both sides. Reflexive property is a freebie. You're allowed to add ticks there. So now I have ticks all the way around. Let's go back and ask yourself which one of these would work, if any. And if you said side, 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 you're correct. The two triangles are congruent by side, 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 and let's just check that order. This says that A goes with C and C goes with A. So they just flip that. And does B match with D? Yes, it does. So yes, our triangles are congruent by side, side, side. So taking a look at this next one, I'm noticing ticks. So I have two sides because I have two sets of ticks, and I have an arc, which means that I have an angle. So I have two sides with an angle, and you have to ask yourself, where is that angle? So I have two sides. Is my angle on the edge? Because if that's the case, it doesn't match. Or is my angle between the sides? And our angle's between the sides, so that's an example of side, angle, side. Now, before I say yes, I just need to check my order. So, does A go with E? Well, yes, it does. A goes with E. And then B should go with F. So, B should go with F. But that's not right, because B is at the end of one tick and F's at the end of two ticks. So, are those two triangles congruent? No, they're not. And that's because they have the wrong order. If I wanted to use side, angle, side, I would need to correct the order. So I could say that triangle ABC is congruent to triangle, and it would be EDF. Remember that order is really, really important. So while they did try to trick us in this problem, that's why we double checked our order. That's why we checked that B didn't go with F. B should go with D. Taking a look at this next one, ask yourself first, are there any freebies that we have that we could mark? And we do have a freebie. It's right here. They share that side, so I'm going to go ahead and add in some ticks right there. And remember, that's reflexive property. Now, I see that they have two sides in common, so they have that side in common, they have that side in common. So I could ask myself, is it side, angle, side? Is my angle between the sides? And it's not. It's on the edge. But there's something special about this angle, and that's that box means that it's a right triangle. And if we think back, there was one that worked for right triangles, and that was HL. Now, we need to establish these three things in order for us to use HL. So let's go through. Is it a right triangle? Yes. Do the hypotenuses match? Yes. And do they have one leg in common? Yes. So it's probably HL, but let's go ahead and check that order. Does ADC match with BDC? Yes. So then we can say our triangles are congruent by HL. And that's it. Taking a look at this next one, I'm noticing right off the bat that there's right angles in there. So I'm going to give you a minute to think about, what do you think that this one is? Go through this little checklist up here and ask yourself, which one would work for this? Okay, so let's go through. Is it side, angle, side? No, because I don't have two sides, and my angle is across from the side, so it can't be side, angle, side. Is it side, side, side? No, because I don't have ticks all the way around. Is it, so side, angle, side, 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 side. Is it angle, side, angle? Well, it can't be because I only have one angle, so I don't have enough there. Is it angle, angle, side? Don't have enough there. And then what about HL? Well, it's a right triangle. The hypotenuses match, but do I have a leg? No. So are these two triangles congruent? No, because there's not enough information for me to figure it out. Now, this one, you might be asking yourself, similar to what we had in the last one, like, are these triangles congruent? Is there anything that we could mark, any freebies in this one? So I'm going to give you a minute to think, are there any freebies that we can mark in this one? And here's your hint. If you said vertical angles, you're right. We can mark arcs in there for vertical angles, so that's our freebie in this one. So vertical angles. So I see that they have a side, they have another side, so they have two sides and an angle. Well, it makes a big difference where that angle is, because if it's side, side, angle, that doesn't work, but if it's side, angle, side, it does. So asking ourselves, is it side, side, angle? Is my angle on the edge of the sides, or is it side, angle, side, where my angle is between the sides? And it's side, angle, side, so let's check that order really quickly before we say yes by side, angle, side. Does A go with C? Yes. Does B go with D? Yes. So yes, our two triangles are congruent by side, angle, side. So taking a look at this next one, remember to always mark your freebies first. So this right here is a freebie, and think back, there's a property that allows me to add ticks. And that property is, hopefully you said reflexive property, because that's the property that allows us to add ticks right there. AB is the same in both triangles. Whether I'm looking at the top triangle or the bottom triangle, AB is not changing, therefore it's reflexive property. I could put ticks on there. So asking yourself, is ACB congruent to ADC? I have two sides and an angle between, so yes, by side, angle, side, they are congruent. And for our last one, you'll notice that there's no letters. And I really like these ones best because it's not like this one up here where it tries to trick you and give you the wrong order. And one like this, all that you have to do is just figure out yes or no. Are they congruent? Yes or no. So I'm going to give you a minute asking yourself, do you have any freebies? Yes or no? What are you thinking? Hopefully you said yes to a freebie, so yes, I can add ticks there. And once I do that, I've established that my triangles are congruent by side, angle, side. Notice the two matching sides with ticks and the angle between. And we're going to do some more practice in just a bit, but I would make sure that you have this chart easily accessible, so as you're going through your practice, you can just go through your checklist.